derivative would be similar itself times natural log of a. Same thing happens here. If this natural log becomes log base something else, the derivative follows the same type of rule, 1 over the stuff inside the log, so 1 over x, times natural log of the base. But the natural log of the base goes here. Just like it went next to that derivative, it went here. Okay, so the derivative of this then, so the rest stay. There's no derivative on the rest, you're done with them. That's the number 1 here. Plus x. The derivative of this is 1 over x times log base the base. And of course you can simplify. I would advise against it in an exam. So questions?
Yeah, so back to like what the function was originally, can I not just do like ln of x plus ln base 2 of x and just derive those two
Plus
separate?
this
Yeah.
thing is, so you're saying to me, take this and tell me what to do. Say it again.
Like there was x in front of the log.
Oh yes, tell me
So
what
like
to do.
ln of x plus ln log base 2 of x.
Yes. So the reason you can do that, because you learned that 8 log of a product, any log, natural log or whatever, is the log of one plus the log of the other. So yes, you can do that. You can write
Okay.
this as a sum. And then take the derivative, right? Which is going to be 1 over x plus the log of anything is 1 over the thing times the derivative of the thing. Yes?
Yeah.
Yeah. So it would look slightly different, but if you simplify it and I simplify it and we write one fraction and I write one fraction, we're going to end up with the same thing. One only hopes. It should
Okay.
be the same.
Sounds good. Thank you.
Yeah. All right. So questions? So about it, 3 problems total on the review. Number 7. There's a practice exam. Can you tell me what number 7 starts with? Because there are a few practice things moving around, so I don't know which one you're talking about. What does it start with? F2 is equal to 5. Yes, okay. I have it in front of me. Okay, so you have right, so this is a pretty interesting problem actually. So let's do that. So you have f of 2 is equal to 5. So that means 2, 5 is on graph of f. Since we're here, before I see what the rest of it is, if I know that 2, 5 is on the graph of f, what point is certainly on the graph of f inverse? Just in case somebody asks. F2, exactly. So if 2, 5 is on the graph of a function, 5, 2 is on the graph of the inverse. Okay, so we keep that inside. F inverse of 2 is equal to -3. Okay, so let's go back, right? So we know the slope for f when x is equal to 2, this is -3, the slope of the tangent, right? So let's go on the inverse. What's the corresponding x coordinate where I know the slope on the graph of the inverse? What x coordinate I should be looking at? If I know this slope, I also know another slope on the inverse. So if this is your x, and you know the slope at that x for the function, you also know the slope at that x, at x equal not -3, at x equal 5. So these get reversed. So if you know the slope on the graph of a function, here's your, and you know the slope here, oops, is equal to -3. Then the inverse, you know the slope on the inverse. on the corresponding point. So this is the point 2,5. This will be the point 5,2. So you know the slope when x equals 5, and that slope will be the reciprocal. Okay, so that's -1/3 when x is equal to 5. Right? Now, why am I thinking of inverse? Because I read the problem slightly, barely read it, right? I see an F, I see an F prime, and when I look down the questions, I see an F inverse. Right? And in the given, I don't know much about F inverse. So whenever I read something about the function, immediately I try to write down what it is I know about the inverse, because the question is going to show up. Right? So I have this information. Right? So again, I know F of 2 is equal to 5. F prime of 2 is equal to -3. I'm also given that G is equal to that. And they're invertible, they have inverses, that's good to know. So find the equation of, so right, so it's all equations for tangent lines. Of tangent to F at y equal 2. So that would be y equal F of 2 plus F prime of 2 x minus 2. And I'm given both that and that. So I can write this, right? So y is equal to F of 2 is 5, F prime of 2 is -3, put a parenthesis there. I never do this in an exam. That's it. It's like elementary school. Don't do that. Okay, that's it. Would you simplify it? Absolutely not. So I take this information again here. So now I'm looking at the second question. So the second question is asking the same type of question, but for the tangent, for the inverse function. So find the tangent of F inverse at, clearly they're going to ask you at 5, right? If this is the x is equal to 2 on the function, then you know what's happening at x equal to the y coordinate, x equal to 5 on the inverse. So they do say at x equal 5. Right? If you know these two piece of information on the function, you know the similar piece of information for the inverse at x equal 5. So you know F inverse at 5 is going to be 2, right? The x and the y coordinates are reverse, right? And F inverse derivative at 5 is not going to be -3, it's going to be -1/3. So I have both pieces of information, I can write the tangent. So the tangent will be F inverse at 5 plus F inverse derivative of 5 x minus 5. So this is the 2, is the x coordinate for the original function, right? This has been, we got the reciprocal of that. And then x minus 5. So if you look at the inverse and you look at the tangent for the original function, if you have one, you should immediately be able to write the other, right? So notice these things have been reversed, right? Right. And the other number in between, what colors we use? This, you find the reciprocal of it. So if you know one, you should know the tangent line on the inverse. Okay, the x and the y is reverse places, and the slope becomes the reciprocal. Okay, so these are the easiest of the 4 questions there. Then you have, right, and then you're asked something about linear approximation, approximate G of 1. So when they're asking you to use linear approximation to approximate G of 1, again, they're asking you to write the equation of the tangent line first. So similar question, write the equation of the tangent line, then do something with it. So first, let's find the equation of the tangent line. So G again was x to the 3rd f. We're told f of 2 is 5, and f prime of 2 is equal to -3, right? So in order to find the tangent line to G, it can only be at 2. Oh, so 1? Okay, oh, so they want to approximate G of 1. But they do say to you, find the tangent line at 2, because you only know f at 2. So at x equal 2, that tangent line will look like g of 2 plus g prime of 2 x minus 2. So x minus 2 is done. I need this and I need this, right? So since g is equal to x to the third f, that means g prime, so I'm going to use the product rule here. So 3x squared times f plus x to the third times f prime. So g of 2, so I'm going to plug in 2, is 2 to the third times f of 2, which is, again, if I was an exam, I would leave it 2 to the third, because you never know, you might write 6. It's an exam. Things happen. So f of 2 is 5. Again, if that was an exam, I would write 2 to the third times 5, no simplification. G prime of 2, because I need the slope, so I just plug in. So that's going to be 3 times 2 squared times f of 2 plus 2 to the third times f prime of 2. This is 5. I mean, this is a nice number, but again, leave it alone. And f prime of 2 was -3. So this is the number that goes here. Again, I wouldn't bother multiplying, wouldn't bother adding, because if you do a mistake, that will be graded. I'll just go ahead and write the whole thing here. Or say, oh, by the way, this goes here. That's fine. Okay. And then what's g of 2? That goes right there. And you have it. The tangent line. Of course, that was not the question. The question was approximate g of 1. Well, the only way to approximate g of 1 is to say g of 1. So this is the equation of the tangent line. Right? Let's call this L of x. So this is the y coordinate on the tangent. So L of x is g of 2 plus g prime of 2, both of which we found, whatever they may be. One is 40 and one is well, something not 40, negative number. So this is telling you, you have a graph of whatever, some function g, and you went at x equal 2. I'm not saying that the tangent line will be going up from left to right, but I'm not going to bother. It shouldn't. It's actually the negative. But anyway, let's pretend this is 2, and you draw a tangent line, and they're asking you, go ahead and approximate g of 1. Tell me what the y coordinate is there. So you don't have a g to plug in. Well, you do, but you don't know what f of 1 is, so you can't plug in. Right? Plus, I'm telling you, use linear approximation, meaning write the equation of the tangent line to the graph of g and then plug in x equal 1 into that equation. So you're going to take that tangent line and you're going to plug in x equal 1 into it. So you're going to say g of 1 that I need is approximately equal to what I get when I plug in 1 into the tangent line. So you're going to plug in 1 there. For what? For x. So the x here is going to be replaced by 1. There's nowhere else that there's an x, right? L of 1, this is a constant, that's a constant that we found, and this is going to be 1 minus 2. So this is going to be g of 2, which is 40, plus g prime of 2, which is some negative number, 1 minus 2. Of course, do plug in the number here, and do plug in whatever the number is there, and then 1 minus 2. That's it, and leave it. You will also be told in an exam, leave things alone. Don't add. Oh, there's more question. So the other question was, okay, so again, it's all about functions and the inverses. So you say, so I have g of 2 is 40, I thought, is it? So 8 times 5 is 40. So g prime of 2, unfortunately, we're going to have to find that. So let's see what it is. G prime of 2 is is 20, or no, it's 40 times 3, so 120. Oh, it is positive, that's good. So minus 24, right? So it's, let's say 96 or something, whatever. Again, I wouldn't add, I would leave it as is. I would even leave it like that and put a big parenthesis around it. So if you know g of 2 and you know g prime of 2, and you know 2 comma 40 is on the graph of g, then what point is on the graph of G inverse? It's the same type of question. A and B is similar to C and D. Well, C is a little different. 40, yeah, 40 comma 2. So the only thing that they can ask about G inverse is write the equation of the tangent line to G inverse at 40, right? And they do say that, only in a weird way. They say write the tangent line to G inverse at, and look at the x equal G of 2, and like, what? What's G of 2? 40. So they're saying at x equal 40. Because that's the only thing you can do. If you know 2 comma 40, what's happening on the function, then you know what's happening on the inverse at 40 comma 2. So x equal 40. So if you know the equation of the tangent line to G, so G, the equation of the tangent line was 40 plus this number, that was the slope, x minus 2. For the inverse, the equation of the tangent line, again, these are going to reverse positions. The x and the y reverse positions, right? So this is going to be 2 plus that flips x minus. So B and D are the same exact type of question. Right, so if you have, so if you have, so if somebody's asking you, so you have a graph, let's say it goes like this. That's supposed to be horizontal. And then it goes up and then it goes down. So let's say they're all kind of linear, don't have to be. So this is the velocity graph, right? So if the velocity, so let's say, right, so somebody's asking you, one is this positive, the acceleration is the derivative of the velocity. So acceleration is the slope of the velocity function, the slope. So we're saying to you, when is acceleration positive? We're asking you, when is the slope positive? They don't say not negative. They say exactly positive. Make sure it's not 0, right? So you cannot tell me if this, let's say, if this was the number, I don't know, 10, and this was the number 8, and this is the number, I don't know, 13. I better use that, but let's say 14, so on. It's positive where the slope is strictly positive, right? So you cannot say it's positive from 13 to 14, including 13 and 14, right? Why? Because at 14 and 13, there are corners. There's no derivative there. Right? So you can't talk about that. If somebody asks a question about derivative and acceleration is a question about derivative, you can't talk about place on the graph where there are corners. So that has to be a strict inequality. So you'll say where t goes from 13 to 14, because that's where the slope is positive. If they ask you where the acceleration is negative, you're going to say from 8 to 10, not including 8, because nobody knows what's happening at 8. Maybe it's the end, right, of the road. So at the cliff, there is no derivative. Or at the corner, there's no derivative. Right? 10 is not going to be included. Where else it's negative? Also here is negative from 14 to whatever this number is here. Right, so those have to be strict inequalities. So, for example, 13, 16. Okay, 13. There's a 13 and 16. Okay, so you're talking about, I don't know what 16 is, because the 16 I'm looking at doesn't have to do with that. So the on the 16 question review. What does that mean? Number 13 on the 16 question. What do you mean by that? Yeah, so the 13 is the one with the picture, right? So the 13 is a velocity graph, so it goes like this. Then it goes like that. Then it goes, and then it goes bloop, and then like that. And then back to, that's supposed to be horizontal. And then back to here. This is the t-axis. So this is the velocity graph, right? So 1 through 5, all 5 problems. I'm gonna be here till tomorrow. There's specifically 2 problems there you should do. Not all of them. Most of the problems I have there, they're a little bit too much for an exam. Oh, the 5th, okay, yeah. Which one is that? The one with the clock? No. Anyway, whatever. So we'll do that next. Just remind me. All right. So you have this thing, and then you're asked to find to answer that question. So for example, when the particle moving to the right? Okay, you said perfect. Here's by the way the v-axis. So here we're assuming, did it say? Yeah. So it does tell you. It says the position, the positive direction is to the right, right? So that means if somebody tells you they're moving with a velocity -12, that means they're not moving to the right. Okay, so so you're moving to the right if the velocity is positive, and you're moving to the left if the velocity is negative. A velocity is the y coordinate here on the graph. So if the y coordinate is positive, then you're moving to the right, right? If the y coordinate is negative, strictly negative, you're moving to the left, and you'll say, okay, what's happening when the y coordinate is 0? Then you are not moving there for a while. You can tell. Why? Because the velocity is 0. You're not moving. You stop. Maybe you're having a coffee, like I do right now. Right? So you stop there. Here you have a coffee. There you have an ice cream. You're relaxing. Well, that's not 0. Here's 0. Okay, so when are you moving to the right? You're moving to the right where the velocity is positive, so you're moving to the right from 0 to this point. Again, strictly positive. So this is 0, and that's 2. So you're moving to the right when t goes from 0 to 2. These are strict inequalities, right? Because the velocity has to be non-zero. But you could use this if you want to, don't have to. Nobody's going to know. You're moving to the right also here because the y coordinate is positive. You're moving to the right from here to here. So all these t values, you're moving to the right. So I don't know, from 3 to, what is that? Oh, it is 3 to 6, right? Also from 3 to 6, you're moving to the right. And you're moving to the right everywhere else where the thing is positive. Nowhere else is positive. Everywhere else you're moving to the left. So, well, except where it's 0. So when the velocity is negative, so at those points, you're moving to the left. So you're moving towards the left from t equals 6 to t equals 12. Okay. That was the first question. And then, well, that was only to the right, so that should be the answer. So when is the particle stationary? So that means for more than an instant, that is more than 1 second. So it's stationary here at exactly 1 second. It's moving to the right, and then it turns around and moves to the left. This is when you make a turn, but you're still driving at that point, right? You just temporarily turn the car and go in the opposite direction. But more than an instant from here to here, you stopped. You're doing something other than moving, right? So stationary is here for more than an instant. Here's an instant. That's not what they're asking. What else is stationary? Nowhere else is stationary. Velocity has to be 0. Stationary means there's no velocity, either positive to the right or negative that makes you move to the left, right? So that would be from 2 to 3. Again, those have to be strict inequalities, right? You could use here that type of inequality. That's fine, because here you also stop. You're exactly at 0, so that's okay to do here. If you don't, again, not a problem. So what is the greatest speed? Speed is the absolute value of the velocity. So they're asking you, look at all the velocity values, look at all the y coordinates, positive and negative. So you have positive y coordinates, you have negative y coordinates, and here you have 0 y coordinates. Out of all those positive and negative and 0 y coordinates, pick the one that has the largest absolute value. So if you want a very large absolute value, that's speed. You need to be far away from the horizontal axis, as far as possible. So the one place on the graph that's furthest away from the horizontal axis is this part. And this part, I think it's this part. Yeah, that's the furthest away. This has a height of, but this is 4 units away. Right? So the largest speed here, the velocity is -4. So that means speed, which is absolute value, is 4. So nowhere else speed is more than 4. Right? So when they're asking you when you're moving with the largest speed, you're moving from this point, whatever that is, 8, I think, from 8 to 10. Again, use strict inequalities in all this problem, I would say. There's, again, a couple places where you can use less than or equal to. That would be this place. But, you know, just stick with strict inequalities. When is the particle's acceleration negative? Again, acceleration is the slope. So you're looking at the graph and you find where on the graph the slope is negative. That is which part of the graph is decreasing, right? Any part of the graph that's decreasing, the acceleration is negative. The last 2 questions are a bit more interesting. So the exact acceleration at t equal 6. So that they're asking you what this is equal to exactly. All right, so acceleration is the slope. So they're asking you find the slope of the tangent line to the graph of velocity at t equals 6. So you go to the graph at t equals 6, and it looks like this. So here's where 6 is. This is the t-axis. And this is the point 5,2. And this is the point something else. 8,-4. And this is where 6 is. So they want to know the slope of the tangent. So here's the graph of this is part of the graph of the velocity function. And there's more to it, right? It goes on here, and then it goes on there, and so on. So here's the velocity graph. So in order to find this number, you need to look at the graph exactly at t equals 6 and figure out the slope of the tangent. But that's not hard to do, because at t equals 6, the graph around there is linear, right? So t equals 6 belongs on this part. And that's a line. So they're asking you, Find the slope of that line. Find the slope of the line, you need 2 points. You have 2 points. This one and this one. And you can find the slope. So that will be the change in y coordinates. So you can go from the top to the bottom or from the bottom to the top. But whatever y coordinate you're going to start with, in the denominator, you have to start with the same x coordinate. So I'm going to start with the top, 2 minus the other y coordinates. I'm going to start with that x coordinate as well. 5 minus the other x coordinate. So that's going to be whatever it is. Again, if that was an exam, I would leave this like that. Right? Because you're afraid of making mistakes. If you make a mistake, it's going to be graded. Right. So like it says here, this problem, if that was, that's an if. If that was a question in the exam, there will be no partial credit. Actually, you've done everything. This is correct. And you write, I don't know, you write -2 over something. That's 0. Although you have the correct answer, right? So you need to not simplify this at all. So that's the slope. That's acceleration. And the other interesting question in this problem is the last one. That says, find the average acceleration. Again, acceleration, by the way, from t equal 2 to t equal 5. Acceleration is the derivative of the slope. Oh, give me a minute. I mean, my computer's ago. Um, so the derivative, remember, is this thing. Limit as h goes to 0 of v of 5 in this, oh, actually, it will be something, a plus h minus v of a over h. That's what derivative looks like. That's the definition. When they're saying the average acceleration, they're asking you to write something like that, where the points in question are 5 and 2. Right? So they're asking you to do this. V of 5 minus V of 2 over 5 minus 2. And I'm assuming here, you should be able to tell exactly what the y coordinate is on the graph of the velocity when the x coordinate, when the t coordinate is 5. Hopefully that's something you can tell from the graph, and you can. Because you know on the graph of V, there's a point with coordinates 5, 2, and there's a point with coordinates 2, 0, right? So the graph looks like this. So this is the point, that's 5 here. This is the point 5, 2, and this is right on the t-axis. This is 2, so this is the point 2, 0. So v of 2, the y coordinate, this is 0, and this number is 2. So this is going to be 2 minus 0, 5 minus 2. Again, we this like that. Don't simplify. Number 15. I mean, in the last, the updated one, I've updated because I had one more problem at the end. That's a good problem. All of those are good problems. We should do them all of them. No, don't even know what 12 is. Okay, so 12, okay. Okay, so let me say something about, not necessarily 12, about derivatives. You cannot come to the exam without knowing the following. First of all, you should know the product rule, you should know the quotient rule, you should know logarithm differentiation, chain rule clearly, and you should know the following derivatives without messing them up, because some of those problems will be full credit or 0. if you do a tiny little mistake, there are going to be some derivatives that are long, and it's so easy to have a tiny little mistake. Avoid the urge to simplify. If you're simplifying correctly, it will be a 0. Do not simplify. Also, avoid the urge to not include parentheses. They're your friend, include them. Because if you write something and it's incorrect because you forgot the parentheses, it's incorrect, you're going to get 0. So you need to know the derivative of this. You need to know the derivative of this. You need to know the derivative of tangent. You're going to need it. Oh, stop going. All right, you need to know the derivative of sine inverse. You need to know that, absolutely. You need to know the derivative of cosine inverse. You need to know those derivatives. You need to know them. You can't mess them up. You can't forget there's a negative here. You can't forget there's a negative here. You can't forget there's square root on these. Don't forget those. You can't forget there's secant squared here. Right? No those. Yeah, I mean, yeah. So if you know e to the x, then a to the x is similar, only has a log of the base. So again, if you know natural log, which you should, then log base something is going to be similar, but it's going to have, again, a natural log next to it, just like this guy had a natural log next to it, the natural log of the base. So I wouldn't worry too much about that. I don't remember, so I'm not going to give you my word for it. Definitely know these things. Okay, so there was a problem. Some people had said, who was it, like 5 or something, was it? Big problem. So let me, give me a second, I'm trying to work it out. So many versions for this, so hopefully it's the correct version. So let's see. Oh, that problem. Yes, let's do which oh, it's just to verify. Which problem was number 5? Yeah, which problem? Can you give me one word so I know that's the, is that the one with the volume and the surface area? The box, okay, yeah, that's the one. All right, so let's do that one. Which, by the way, similar to the one. Surface. Oh, that's different. Surface area. Oh, yeah, let's do that one. Okay, so fine. 5. Some reason my thing is not opening up. Give me a second. Oh, there it is. All right. So you have a box and you're told, this is a good problem. So this is twice the width. On the height and the width, let's pretend they're the same. X and X, and the other one is twice as big. All right, so you read the problem is like volume, and then you see the word surface area. So before we do anything, let's write the formula for the volume, let's write the formula for the surface area, and then we'll go and look at the questions. Okay. So what would the volume formula be in this case? Right, it's one side times the other side times the other, right? So it's 2x times x times x. Please don't use that 4 times. Because read about it. Okay, so that's the volume formula. Okay, surface area, I think he calls it how would that call it? I know he calls it A, but I might call it S. Oh, I did write it there. Okay. Fine. So the surface area will be, oops, it will be how big this area is on the front, how big the top is, how big the bottom is, area, right? The area of a rectangle is base times height, or length times width. So you want to find the front, which is the same as the back, which by the way is the same as the top, right? The top is the same because the top has, again, one side is 2x and the other side is x. So the front, the back, the top, and the bottom, each one of those looks the same, right? All of them look the same. So each one of those has area 2x times x. So each one of those is 2x squared. And you have 1, 2, 3, 4. One top, one back, one front, right? So 4 of those. So you have 4. Each one of them has this area. And then you have 2 on the side, but they're slightly different. This one and the one on the other side. Those have area x times x, right? So you have 2 of x times x. So altogether, the formula for the area is going to be 8x squared plus 2x squared, so it's 10x squared. Right, so I have those two formulas, and now I'm going to look at the problem. So you read blah, 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 blah. It says the volume is decreasing at a constant rate. So it's always the same. It's increasing with the same, the derivative is the same, it's telling you every time. So constant rate of 5. So the first question is, what's dv dt? What's the answer to that? -5. Number 1, you better get the 5 correct. 2 has to be a negative because it says it's decreasing, right? It's -5, right? So that should be -5. It's telling you what it is in words. I guess the first question should be easy, right? Second question says, okay, write the formula for the surface area. Fine, we wrote it, right? The front, the back, top, and bottom have the same, each one of them has the same area. So there are 4 of those and 2 on the sides. So those 2 on the sides have the same area, right? So 2x squares and then 4 of the 2x squares, right? 2x squares and 4 of the 2's. Okay. So you have that. That's question 2. And then, so again, I'm going to write the V because I'm going to need it. And I'm going to write the A, which we're going to need it. So this is what's given to me. Now, I don't need to read the rest of the, I have a box and I have this. I don't need the rest. I can just look at the question, the last question. So at what rate, so they're asking for the rate, which is a derivative, the surface area, is something happening to it. So they're asking for the derivative of the surface area. When the height was the x. The height is definitely not this, right? Everything has length x except the actual length of this thing, right? So when x is equal to 3, and of course, they're telling you to use correct units. Okay, so now, when they're asking for the derivative of a, so I got away by writing it this way. This is not incorrect, but it's deceiving because different people can think of different things when they read this. So when I say a prime, I'm talking about the derivative of a with respect to what? What variable? With respect to time. It's not with respect to x. So you cannot say dAd of a prime is equal to 2 times 10, 20x, and stop. Because you're not taking the derivative with respect to x. You're taking the derivative with respect to time. How do you know? Because you read hours, hours, hours. That's the derivative with respect to time, right? So dA dt. So when you look at this and you want to find the derivative with respect to time, you think of a as a function of t. You think of x as a function of t that somebody forgot to tell you what it is equal to. So when you take this derivative, you use the chain rule. The 2 comes down, write the x with 1 less power times the derivative of x. That's a 1, and that's a prime. Okay, so the derivative will be 20x times the derivative of x. Let's write it this way, right? So I can figure out exactly what a prime is as long as I know what x is. I do, but I'm missing this. So the whole problem, the last piece, it's twofold question. One is to figure out you're taking the derivative with respect to t and find the dx dt, and 2, mess up the units. Okay, you can mess up the units. So, so I can write down what I know, x is 3. So I'm missing dx dt. So there must be a reason that somebody gave you the derivative of the velocity of the volume. There must be a reason for that, right? This was not just, here's a question that you know the answer immediately is negative, what was it? -5, and then you do nothing with it. Okay. So I know this derivative is -5. So I'm missing this. I have no idea what this is. So I'm going to stop. I can't finish the problem. I need to figure out that number. So I'm going to go back to what I know. I know the derivative here is -5, and I know v is equal to, what was it, 2x to the third. So instead, I'm going to play around with the volume, see what I can do with it. So the derivative of the volume, I need to use chain rule again. 3 times 2 times the derivative of x with respect to t. But I do know that this is -5. I do know x at this moment of time is 3. That will allow me to find the derivative that I want, the x to t. So again, do you have to simplify? No. So I will write this, dx to t is -5 over 6 times 3 squared. Take all this and plug it in here. So I'll write 20 times 3, parenthesis, -5 over parenthesis. 6 times 3 squared. Don't simplify. There's no need. So that's the answer. And now you need the units. But the units are given to you in dA dt. The units are the A units over the T units. A's area, so it's the length squared, whatever the length is. Length was in what? I don't know, feet, meters? Oh, it's meters. Okay, fine. So this is going to be meters squared over hours. Okay. Question? Okay. No, absolutely do not simplify. No, 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 no. We simplified that because, you know, we love making things looking pretty. That's not your goal. Your goal is to do the problem and not lose any points because, you know, you adding and you know, 2 plus 1 and you get 4. It's an exam. You mess up on little things. So find the derivative. So when somebody says, for example, find the derivative of tangent of e to the sine of x squared. Right. So find the derivative of this. You don't panic and you find the derivative. Means you find the derivative of the outside, secant squared, leave the inside as is. Keep on using parentheses, times the derivative of the inside. So this is the same. I would even do that to avoid writing too many things. And now find the derivative of this, which is e to something. The derivative of e to something is itself, times the derivative of the power. So this is the same, times the derivative of sine of stuff. Derivative of sine of stuff is cosine of stuff, times the derivative of the stuff. So this is the same, all that, times 2x. Okay, so don't simplify, use parentheses. Don't simplify anything. Derivatives are pretty straightforward. there's one place where they will tell you what not to do. So one place I would say, in logarithm differentiation, remember, when you have y is equal to some bad stuff. Bad stuff could be, sine of x to, I don't know, x plus 4. So x's to x's, or x to tangent x. X's to x's. Here you're stuck. You need to use logarithmic differentiation to find the derivative. So you use logarithmic differentiation, right? That allows you to get rid of, to split those things up by bringing the power down, whatever you bring it down, right? And when you take the derivative, remember, you're going to be left with this 1 over y on the left, right? So when you find y prime, you have whatever the derivative was here. Do not write the answer this way, and the problem will tell you the answer has to be only with x's. So if you write your answer without leaving the y there as y, that would be a mistake, specifically because the problem told you the y prime has to be just in terms of x's. So don't forget to replace y by whatever it's equal to, right? So that's the one place where you have to do it a little bit more, but the problem will tell you to do that. Yeah, everywhere else you should just not simplify anything, nothing. 2G, does that mean you want to do 2G? Okay, I don't know what 2G is. So you're looking at a different review, the one that, tell me what it starts with. Yeah, I'll do 9, but I don't know what 2G is. Can you, so why is it gonna go low? No. Okay, so we already did that. Right, so we already did that. So there are two ways to do that. So one is to go ahead and think of this as natural log of some stuff, and you want the derivative, so that would be 1 over the stuff. The stuff is all that. That's the stuff. Times the derivative of the stuff. So you really need to go on the side and figure out what the derivative of this guy is. If this guy is a product, so its derivative will be the derivative of the first times the second, plus the first times the derivative of the second. This derivative is obvious. This derivative almost obvious, right? So you need to know what it is, natural log of it. And then you plug in everything and don't forget the parentheses. But there was that was 2G. What was the one after? Somebody. So okay, how far up do you want me to be? Where? Where am I scrolling? Which problem? Here or further down? Sine log. Oh, you mean this thing? Sine log. This thing? No. So you'll definitely have a problem with logarithm differentiation. Definitely. Definitely. So somebody asked for something else. 15, yes. So I already did all 13. 13B is what? The one with stationary point? Is that what the one? The one with the graph? Zainab, can you hear me? Which one is 13B? Is the one that says about particles stationary for more than an instant? It's one of two values. Okay, so I would do 13A through 100 F. I did those, but Right, so for team B again, you have a velocity function. What does it look like? I don't know. Looks like something. So let's say this is the t-axis, and this is the graph of the velocity. That means the graph of the velocity, if this is the velocity axis, the velocity is the y-coordinate, right? If the velocity, if you're moving, the velocity is not zero. The velocity is zero. If I say, what's your speed right now? It says zero. You're not moving, right? Velocity is just speed with a direction. And in this case, direction is either to the right, positive velocity, or to the left, negative velocity. We're living like not the world that we live in, 3D. Okay, so give me a second. So, right, so when are you stationary? You're stationary when means you're in place, you're not moving, when the velocity is equal to zero. Velocity is equal to zero, that's the y-coordinate. So you're stationary over here. You're also stationary here. But this is temporary, this part here. Here the velocity is positive and then it becomes negative. That means you're moving to the right, and now you're moving to the left. How did that happen? You're moving to the right. You're on a line. Your whole world is a line, right? Moving to the right, and then how did you move to the left? You stopped and turned. So here's where the velocity is zero. You don't move, you just turn the car around the other side. So they're saying to you, when is the particle stationary? More than 1 instant. This is just one little point in time where you stay stationary. They're saying for a little longer, right? So when is the velocity zero? For a little longer than 1 second. So velocity zero here. From this point, which is 2, to this 3. So the velocity is 0. Here you could use equal signs. In this problem, avoid all the equal signs, because all of those answers except one does not allow for equal signs. So just get rid of them. So clearly 0 here, velocity, and clearly velocity 0 here. But it's also velocity 0 everywhere in between. So that's more than 1 instant. Right? So that was 13G. So so if you want to do the rest of them, since I already done them, you can stay at the end. I could do the rest of them again. So 9. What's 9? Right. So 9 is a good problem. That's one I added. So you have a function. Then you have, oh, h is the stuff above, right? Yeah, I think that'll create. So you have the graph that looks like this, something like this. So pretend goes like that, pretend goes like that, and then this is open, and does some weird things, it comes around, and has a hole here or something, not a hole there, and then goes on forever. But it goes like that. And this is the number 1. That's the number 3. Nobody believes it, but anyway, let's pretend. And this is the number 4. And this is 6, and goes on. Okay, so they're asking you, the first question is find the derivative of h at 1. So this is h. The derivative is the slope to a tangent, right? Tangent line to the graph of h at x equal 1. So here, what's the slope there? Now, why did somebody pick 1? I could have picked 2. The answer would have been the same. I would have picked 0.1 or 0.2 or 1.1. But the reason I picked 1 Because there will be some people who will say, oh, I know the y-coordinate is 0, so they'll write 0. Which is incorrect, right? So you might not want to do that. If I give you 0.9, you'll say, I don't know what the y-coordinate is, in which case you might have to think a little longer, right? So the slope is really, the derivative is the slope of this line, because the tangent line is exactly the same line, right? So the slope of a line, how do you find it? You need 2 points, and you have 2 points. You have 1, and you have 2 more. So pick the easiest ones for you out of those 3, right? And use them to find the slope. So this is the slope of that red line. Okay, so you need 2 points. So you have a point. I'm going to pick the easy ones. So 0, 1, and I'll pick this one. 1, 0. Right? So the change in y coordinates, so 1 minus 0. And the change in x coordinates in the same direction. So 0 minus 1. And I'm going to check. I'm looking at the line and I see it's going down. So the slope better be negative. And it is, right? So the slope is negative 1. So that's the first question. So another question says, find the, so a lot of them are about limits, right? So find the limit as x goes to 1 from the positive side of h of x. So it says, walk on the graph of h. Why do I say positive? There's no reason. Okay. That's not what I meant. I meant 1 over h, because there's no reason to say h. Okay, so that's easy. Doesn't matter whether you're going from the positive side or from the negative side. If you're on the graph of h and you're going towards x equal 1, from either direction, you're approaching a y coordinate of 0. Right? So this, no, it's a silly question. It would be more interesting to ask you, I think that's what I meant to ask, right? To ask you this question. Because yes, you're approaching 0, but you need to now, 1 over 0 could be positive infinity, or it could be negative infinity. So you gotta be careful. Number 1, you need to know the sign of the numerator. That's clearly positive. Number 2, the 0 is not really a 0. It's something close to 0. So you need to know, is it positive or is it negative? So if you're coming from the right side, so if you're walking this direction from the right side, you're clearly on negative y coordinates. So this 0 is not really 0, it's slightly negative. So this is really negative. So you have a positive over negative, so the answer is negative infinity. Okay. And similarly, I'm asking the question from the other side. So from the other side, the graph looks like that. This is 1. So this is the x-axis. So if you're walking on the graph from the left side, you're here, where the h is clearly positive, but you're approaching a y coordinate of 0, right? Here the y coordinate is 0. So this is 1 over 0, positive, but you're approaching 0 from positive y coordinates. So this is going to be positive infinity. We should copy this up. Add a couple more there. So, oh, I do have 1 from the negative side. Okay, fine. And then you have to find the derivative of 3. What's 3? So the derivative of 3 is right at this point. What's the derivative of this corner? Does not exist. This is where you say does not exist, because it's a corner. Or if it's an edge, does not exist. That does not exist. Okay, and then you're told to find the limit as x goes to 2 from the positive side of h over f. So f again was x minus 6, x minus 2. Clearly f of 2 is 0. Right? So this is 0. Now, if you have 0 over 0, the answer could be anything, literally anything. Any number, including positive or negative things. It could be anything you like. You can't do anything with it because we haven't done enough. So I'm expecting h at 2 is not 0. That number. Okay. So at 2, this is 2 right here. H is some negative number, right? I really don't care what kind of negative number. It's a negative number. So this is a negative number. And the denominator is 0. So I know the answer is going to be positive or negative infinity. We're not going to rush and say negative infinity because there's a negative. Because at 0, I have to specify, is it slightly negative, close to 0, or is it slightly positive, close to 0? So I have to go to 2 from the right side. So think about plugging in not 2. You plug in 2, you get 0. Plug in something slightly more than 2. X is more than 2. Not too much more than 2. Don't plug in 7. Right? So plug in 2.1. Right? 2.1 is going to give you a negative. 2.1 is going to give you a positive. So the answer is going to be negative. So this is not quite 0. Slightly negative. Get close to 0 there. Okay? So the answer is going to be infinity, but it's going to be positive infinity. Okay. I let me about the ones that are like that. So then you have h left, x. There will be one where the answer is going to be an actual number. And the rest are going to be plus or minus infinity, and 1 or 2 does not exist. So, oh, 6. Okay. Let's do the negative first. So 6 was, what's happening with 6? So 6 were here. So if we're going to 6 from, what does it say, left? From the left side first. If you're going to 6 from the left side, on h, you're approaching this y coordinate. And this y coordinate is -1. You're going to 6 from the left, the y coordinate is approaching -1 on h. So the h is approaching -1. Okay. If you're going to 6 from the left, you plug in 6. Right? But a non-zero over 0 is plus or minus infinity. So again, you're forced to specify, okay, this is not really 0. Is it a little bit negative or is it a little bit positive? So you're going to go and pick a number to the left of 0 because that says left. So a number less than 6, slightly less, like 5.9. So if you pick 5.9, just slightly less than 6. 5.9 will make this positive and will make this negative. So the answer is negative. So this is slightly negative. So again, the answer is positive infinity. Okay. So now they're asking you, ways to find this. I wouldn't do that particular question directly. The reason is I'm looking on the graph and there are issues at 6. Both on h has issues, although h is negative, both from the right and on the left of 6. Whether you're going from this direction or that direction to 6, h has negative y coordinates. So h gives you the same answer both times, but the f doesn't, right? So I will do this question in pieces. So instead of answering this, even if that was given to me first, I will first answer that, get positive infinity, and I'm hoping if I take the limit as x close to 6 from the right, I also get positive infinity. If I don't, then my answer will be doesn't exist for this question. Okay, so I'm not going to answer this question until I figure out this answer first. Right, so again, h is negative on the graph, so that's some negative number. Don't really care what it is, some negative number. I know f when I plug in 6, whether from the right or from the left, f gives me 0, so I need to know whether that 0 is positive or negative. Right, it's not really 0. Because the limit is not something you arrive at. You'll never arrive at 6. You'll get closer and closer and closer. So not really 0, right? It's a little bit off from 0. So when you plug in something greater than 6, barely greater, in this case, you can plug in 1,000. So let's say 6.1. you get this number is going to be positive, this number is going to be positive, so this is not quite zero, this is positive. So the answer is negative infinity. So the left limit is positive infinity, the right limit is negative infinity, so this does not exist. Okay, so look, this is what I was asked for. You can't quite do it because you notice the F gives you a little positive or a little negative, depending which direction you're coming from. It gives you different answers. So every time you have a non-zero over zero, you need to wonder what type of number this thing is. Right? You need to put a little sign, plus or minus. So then what was the other question? Yeah, we'll do that. So what's 12? Actually, you're looking at different 12. That's not the 12 I'm looking at. So find constants. So you have y is equal to ax squared plus bx plus c. 0 to this is f. It is on graph of f. And the slope of tangent at x at 3,8 is 3/2. Okay. So I need to have at least 3 pieces of information because I have 3 unknowns. I have 3 pieces of information, and I need to create at least 3 equations that involve A, B, C, so I can solve. Well, I can find C immediately. Why do I know what C is? By looking at this. The y-intercept, it's telling you when x is equal to 0, y is equal to 2. Well, if you plug in 0, you're going to get 0 plus 0 plus c. So c must be 2. Okay, so we know that. So f again is ax plus 2. Then they're telling me all the graph of the function, here's the function. At the point 3,8, something happens. The tangent whose slope is 3/2. They're giving me 2 pieces of information. One, they're giving me another point on the graph, 3,8. So 3,8 satisfies this equation, right? 8 is the y, and 3 is the x. Oops. So I have 9 squared a plus 3b plus 2. So again, I want 2 equations with a and b because I have 2 unknowns a and b, right? So here's one equation. So I'm going to rewrite it. 9a plus 3b is equal to something. And, you can simplify. Let's get rid of some 3's. So 3a plus b is equal to 2. So here's one. I need another one with a's and b's so I can find them. And the other one is this. To tell you the slope. The slope is the derivative of the function at 3. So I'm going to find the derivative of this thing and plug in 3 for x. I should get the slope of 3/2, right? So the derivative is of this function is 2ax plus b. And the derivative at 3 should be 3/2 because that's the slope. So when you plug in 3 for x, I get 6a plus b is equal to 3/2. Okay, get rid of the denominator, please. Don't leave it there. So multiply by 2. So I get 12a plus 2b is equal to 3. Don't subtract. That would be silly. Get rid of the one of the two things. So you can either multiply here by -4 to get it, and then add to get rid of the a's, or you can multiply here. I think I'm going to do that by -2. So I'm going to multiply the top by -2 throughout, including that, and actually multiply correctly, and then at the bottom. So those go away. And once I have A, I can go either here or here. I'm probably going to go here because it's easier and find B. So I add them. So 6A is equal to, I don't know, something. Nobody cares what it is. Once I have A, I can go here and find B. How do you find B? You don't simplify. 3 times A plus B is equal to 2. So my answer would be B is 2 minus this number. I wouldn't dare simplify in the exam. Is it? That's not 2. Why is it 2? So this is 2 plus 1/2. But, you know, again, don't simplify this thing. So, yes, that's a standard little problem. Um, oh, yeah, I put a similar problem in the extra one. What recording? I'm not recording this. There's no recording. No, look at their handwriting. Any other questions? I know there were some other questions. I forgot what they were. So if you have one, what B and C. 13 is the same one with the weird things. Is the picture? Is that the one? I did B again and again. So which one is 13, Gianna? What is it the one with the graph and the velocity again? Or something else? What's that? What's BAC? That'll work. Don't know what that means. Um, okay, send me the link. Could you send me the link so I can go to where you're saying? I don't have it. I have the wrong thing in front of me. Oh, okay. Yeah, send me the link. I don't want to go search. I have a million tabs open. And then I can look at it. Oh, okay. So which one's that? Exam review 2? Is that the one? Let's hope so. And that's problem, say 13. Oh, so that's kind of a similar question as that's a similar question to the one that's there with the other picture. Only this picture is slightly more painful. Can't see it. Anyway, so it's the same question. The one with the velocity here. So you have a graph, you know, whatever. So which one you want to do? B, you said? B and C, okay. So, so B says, estimate the bicycle's, yeah, instantaneous speed. Okay, speed, that's what they mean. At t equal a half, t equal 2, and at t equal 3. Okay. So the speed, is this the velocity graph? Oh, total distance. Okay, so that's the distance. So that's a little different, actually. It's not the same. Yeah. So, so if this is the distance function, right? Velocity is going to be the derivative. Speed is the absolute value of the velocity. So they're saying to you, go ahead and kind of estimate, because that's all you can do. estimate, you're not gonna have a problem with your estimate, because your estimate would be different than the other 140 people, or 50 people, or 70 actually, at the grade, and I'm not gonna accept 20,000 estimates. You're not gonna have estimates. So you can have a nicer graph. But anyway, estimate the slope. So, for example, if this is a point, you draw a tangent line the best way you can. If you see if it touches 2 points, you have 1 point, you need at least 1 more point to figure out the slope. So this is an estimate, because your tangent line, the way you draw it, might not be very good, right? And the second point might fall here, where my second point might fall here. So you and I will have different estimates. So once you have an estimate for the velocity, the absolute value of the velocity is the speed, right? So if the graph goes, let's say, down, the derivative is going to be negative, but the speed is going to be positive. Okay. So, right. So a t equal a half. So everything is going to be an estimate. It's a silly problem. Let me I have to make it bigger. Can't see a thing. All right. So you have this graph. So the first one's what, at the half? So this is 1,8, and this is 0,0, and a half is, well, that's half is in between. So you're kind of pretending here that the tangent line, approximately, you don't know, right? We will go through this point. It's all pretend. You can do that if you want to. You can use this point and that point. So, okay, so you know anything about a half? Okay, you do. You know at the half, the y-coordinate seems to be 2. So perhaps you can use this point and that point. But maybe your friend next to you could have used this point and that point. Would it have been wrong? No, not necessarily. I mean, I don't know. Well, I guess it would be a little bit wrong. Right, but these are estimates. If you use those 2 points to pretend that that will give you the slope of the tangent at this point, you're incorrect. But it's an okay estimate, right? This is a bad question. That you're gonna be given something where you don't have to estimate, except if some linearization, which is a tangent line, right? Yeah, that's a silly problem. So yeah, don't look at that. It's bad. So yeah, so I wouldn't do B. It's all estimates. Is everything about estimates? Yeah, everything's about estimates. It's so silly. So don't do that one, because you can't tell what things are. If you're gonna have a graph, it's not gonna be so curvy. At least at the places where we're gonna ask a question, you're gonna have lines where you can tell derivatives. You can tell slopes of tangents. This you can't. So yeah, move on from there. It's terrible. C was the same. Right. So C is the same, right? Estimate the maximum speed. So again, speed is the absolute value of the velocity. So velocity is the derivative, and derivative can be positive or negative. So you just by looking at this thing, you think of tangent lines everywhere, and you say, where should that be? So the tangent line looks like it's increasing or decreasing as fast as possible. In this case, all the tangent lines seem to be going up. So the tangent lines seem to be, the steepest, right? The steepest tangent line, whether it's going steeply down or up, it's going to have a very large absolute value for the slope, right? So again, that's an estimate. So you could say, I don't know, what does it look like? So the graph, I mean, clearly at 2, you don't have a very steep tangent line. It looks horizontal. So around 1, I would say, but maybe it's not exactly 1. Maybe it's a little higher than 1, or maybe around 1. But again, it's an estimate. So around 1, it looks like it has the largest velocity, the largest slope on the graph. So again, what is that slope? kind of had to figure out in the previous question. And whatever the slope was at 1, or you think it is, because everything is an estimate, the absolute value of that, which you don't need absolute value because everything is positive already, all the slopes are positive, the absolute value of that is the speed. So again, don't worry about this problem. It's bad. It's all about estimates. Don't want to do that. Okay. All right. Any other questions? You should look at all the questions on the last review that we have on our site, all of them. Yeah, these are good questions. And not the derivatives that I mentioned. Not the derivatives of trig function, sine, cosine, tangent, not the derivatives of sine, and derivative of arc cosine. What do you mean limits? Like, what do you mean by that? Well, so like the question we did, yeah, on our Canvas site. The all sections, I didn't even notice this was there. I would have told you not to do this problem. That's silly. There's some other, okay, so there's some other problems from years ago here. Okay, so whatever. This is okay. Okay, so do all the problems with do the derivative problems here. Okay, so the problems with, okay, definition of the derivative, like problem, what problem is that? 20,000 parts. Do that one. Problem number 7 in that review is good because it says here's a find the derivative, find the derivative, find the derivative. So, and there's some long products. And so do that problem. That's a good problem. There must be a problem somewhere. Cotangent, don't know that. Like also these derivatives again. Oh yeah. So number 7 is good, and number whatever this number is, number 2 also derivatives. Do all of those. And there should be somewhere a problem with logarithmic differentiation. Do that, but again, if you look at the other review that's posted on our Canvas site, that's good. And any problem that you find similar to those, do more of those types. Okay. Limit questions, I think there is one limit question that I've added to on our Canvas site to that review that I mentioned here with the, the H and the F, weird limits of all types. Do those. I don't know if there's one on the other site that you use somewhere. I haven't looked at that, so it has some good problems. Anything with derivative, like find the derivative, just do those for practice. Which one? Mariam, which would you say that one? Are you talking about a single problem? Oh, the limit one? Okay. Yeah, okay, fine. Fine, you can send me an email. Send me an email. Say, can you do problem number, what's that? 9, the new problem 9 with the limits. Can you write solutions? Just send it out. So I'll forget it. I'll say yes, and then I'll go and watch Barton Block or something. Okay. Any questions? Mm, 17. No, you can't. I added those. Yeah, can't find answers to those. Although we just did, we did something like 17. 16 and 17 are, well, kind of similar. So 16, so I've added 16 and 17. So 16 says, it's similar to the one we did. So it says 0, 11 is on graph of F. So that tells you C is equal to what? That tells you when X is equal to 0, the Y is 11. So you're saying you're given like a distance graph or something? Or what? But the answer is no to your question, Elisa. No, don't worry about that. Anyway, so okay, so that tells you if you plug in 0 inside here for X, the Y coordinate is going to become 11. So what does that tell you about this value of C? What do you see? Plug in 0 for X, here's an X, and here's an X. If you make those both 0, the Y coordinate, here's the Y coordinate, is going to become 11. So C must be 11. Right? This is the C, right? In problem 17, same thing. F, which is the Y coordinate, is ax squared plus bx plus c. And I say to you, 0, negative 10 is on the graph. So guess what c is? Negative 10, right? So y is equal to ax squared plus bx minus 10. So here, y is equal to ax squared plus bx plus 11. So now since you have two unknowns in both problems, you need two equations and two equations, two for that problem and two for the other problem to find the ABs. Right? So that's done. So then this problem tells you the first one. So you have this. So now you need some more information. It tells you that 1, negative 1 and 0, 11. Okay. That was clearly not. Wait, when I wrote that. Oh, I see. Yes. Okay. Fine. 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 I was late. Okay. Are on the graph of tangent to F at x equal 1. Guess what the y coordinate is on this tangent line when x is equal to 1? What's the y coordinate? These are both points on the tangent, so the y coordinate better be negative 1. You can have the same x coordinate with different y coordinates. There's only one point on the line with x coordinate 1. That's the one. So that means the graph of the function goes through that point because that's where you draw the tangent line on the graph of the function at x equal 1. So here's f, and here's the tangent line. So you're given two pieces of information. This point is on the graph of the function, as well as the tangent line, because you took the tangent there. So this also satisfies the equation of that function, right? So 1, negative 1 is on f. So this is x, and that's y. So I'm going to plug them in. So I'm going to have another equation with just a's and b's. So I get y coordinate, which is negative 1, is equal to 1, a plus b plus 11. So that gives me an equation with a's and b's. I need one more. Okay. So I'm told this is another point But I guess the tangent line goes this way. Nobody cares. But anyway, so this is another point on the graph of the tangent line. But that point doesn't belong on the function necessarily. I don't know, right? This point does. So I need to write down that something about the tangent line, the equation of the tangent line. Oh, I haven't given enough information. Yeah, I have, okay. Okay, this is 16. I don't know what I was thinking of. Okay, so you have a tangent line and you have 2 points on it. You can write the equation of the tangent line. Why? Because it's a line. It's enough to have a slope and a point, or 2 points. You have 2 points. You can write the equation, right? So the equation of the tangent line would be y1 plus slope x minus x1. y1, x1 could be one of those 2 points, whichever you like best. I don't know which one you like best. Let's use that one. x1, y1. It really doesn't matter which one you're going to use as your x1, y1. Okay? So the equation of the tangent line is y1, 11, plus slope, don't know yet, x minus x1, which is 0. So I'm going to simplify y or 11 plus mx. So I need the slope. How do I find the slope? I can do it because I have 2 points. So the slope is going to be the change in the y coordinates, 11 minus the other y coordinate, over the change in the x coordinate, the 0, that goes with 11, minus the other x coordinate. So this is going to be, so it's negative 12. So y is equal to 11 minus 12x. Okay. Does that help me? Well, let's see. So I have a function, and I have a tangent line. It's supposed to have a negative slope, but let's pretend we didn't notice that. So the slope is negative at x equal 1. But the slope is the derivative. So the derivative at x equal 1 must be negative 12. The function was ax squared plus bx plus 11. Plus 11. The derivative of the function, which is the slope of the tangent, is 2ax plus b. And the derivative, when you plug in x equal 1, should be negative 12. So let's plug x equal 1. So 2a plus b must be negative 12. So here's an equation. And here's the other equation. Where's it? I lost it. Here's the other one. And those should be enough to find it. We have 1. And the other one's a plus b was equal to negative 12. Get rid of the b's. Okay. The other one is similar to the one we did before earlier today. So you have ax squared plus bx plus c. This is your function f. A 0 negative 10 is on f. So therefore c is negative 10. Because when you plug in 0 and 0, you get negative 10. Okay? And then you're told that this function that looks like this now is such that at 1, negative 3 on the graph of the function, the tangent line has slope 12. The slope is the derivative at 1. The derivative at 1, you take the derivative, 2ax plus b, and you plug in x equal 1. That derivative got to be 12. So 12 is equal to 2a plus b. Didn't I just do that? Oh, that's similar to the other one. Yes. So that's 1. But there is another piece of information. Another piece of information is that this point is on the graph of both the tangent and the function. So this point, I haven't used negative 3 in there. This point belongs on this, the graph of this function. So it satisfies the equation. Satisfies this equation. So I can plug it in. X equal this, y is equal to that. Right? So we have a plus b minus that. So here's an equation, here's another equation. You work slowly, we can find a's and b's. And you already have c. Okay, questions? You should do all of these. Anything else? Okay, so is there a 17 or is there no, you should go and look, did you look online on our Canvas site? There's a 17, there's an 18. So I like odd numbers, so I added an 18. Wait a minute, what section are you in? 17. Give me a second. Should I post it in both? Okay, give me a second. Are you looking at the solutions, Mariam? Just look at the non-solutions. I forgot to add it to, yeah. Oh, I didn't add it. Oh, that's not good. I'm gonna erase. Give me a second. And, wait a second. Hold on. Yeah, you're right. Just a second. So I'm gonna erase this and put the other one. So now if you go and reload the page, there should be, don't look at the solutions. I didn't add it to the solutions, I don't think, did I? I think I added a couple. The solutions I didn't add the last one. Yeah, I've added 2 in the solutions. I didn't add the third one. So, but if you look at the actual problems, the practice exam, not the solutions, you will see the 3 additional problems, 2 of which show up in the solutions with no solution. So if you want to write it. Okay. Okay. Oh, exam, that's what you meant. E2 means exam 2. Yes. All right, so any last minute questions? So if there are more questions, I can have more office hours tomorrow. So go through the practice problems that I've posted on our Canvas site. Do those, all of them. Okay. And then if you have a question, send me an email. And you know, tell me which thing you're looking at. Don't say 12, because I don't know which file you're looking at. Are you looking at our Canvas site or are you looking on the other side? Right? Okay. All right. 17, what was 17? Oh yeah. So 17 was, oh, this one here. So this one here, we knew C was -10. right? C is -10. Oh, there it is. C is -10. And then we have to solve those two. So we have 2a plus b is 12. That's this one. And then we have a plus b is equal to -3 plus 10 is 7. You really have to go slow here. If I was an exam question, you have to really question yourself constantly when you're adding and subtracting. If you do one mistake, everything is wrong. Right? So I can subtract here because it's easy. Those have the same coefficients. I can subtract. But if that was not the case, that was like this, and that was like that, then I just want to make either the a's opposite coefficients or the b's. It would have been easier to do the b's. I would multiply this by -4, so the b's would be opposite, and then I will add, right? In this case, it's easy. I just subtract 2a minus a is a, b minus b is 0, 12 minus 7 is 5. You go slowly on that. So now you have a is 5. And now that you know a, you can go either here or here to find b. So now you have a, b, c. Okay. So again, a is 5, b is don't know. So if a is 5, that's 10, so b must be 2. And c was -10 in this case. Right, so for example, if you have, right, so if you have something like that, so you have 2a plus b is equal to 12. You have two options. One, and it's case, because one of the variables, well, the unknowns, not the variable, the b in this case, has a coefficient of 1. Because the one of the coefficients is 1, you could, if you wanted, use substitution. Solve for b. I don't like that, but you know, some people do. So solve for b, 12 minus 2a, and then go plug in that for b, multiply that for blah, 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 find a. So that's one thing. I don't do that. So I would like the coefficients of either a or b to be exactly opposite. So if one is 10, the other one's -10. So it's easier to do it with the b's. So one of the b's is a coefficient of 4, and I'd like the other one to have a coefficient of -4. So I'm going to multiply the whole thing here by -4. The bottom stays as is, because I want the b coefficients to be opposite. So I'm going to keep the bottom as is. So 3a plus 4b is equal to 7. And multiply this by -4, everything. So -8a minus 4b is equal, and again, go slowly here, minus 48. And I'm going to add that because I want to get rid of one of them. Right? So you have -5a is equal to something terrible if you add them up. Right? So a is equal to horrible. And then you go here and find b. Again, I will go to the easiest one, and I'll say b is 12 minus twice a. I will simplify the a, leave it alone. That's b. Don't simplify anything of it. Nothing. Okay? All right, so I'm going to go. So I have my show coming up. So if you have questions, send me an email. I can have office hours again tomorrow evening after all my gardening. Good luck, study, look at the problems on our Canvas site. Look at those first. Okay. Have a good night, everyone. Well, I'll have a good night. You can study. Okay.